So the first part I start out with to graph a linear inequality in two variables. In other words, there will be x's and y's involved. Graph the boundary line. That's the first thing we're going to do is graph a boundary line. We'll make it a solid line if the inequality symbol is what? When do we make the boundary line solid? What did you learn in your reading? Less than or equal to? Or what's another possible time that we would make the boundary line solid? Greater than or equal to. So in other words, when the equal to bar is included, we're making the boundary line solid, just like when we were doing it in one variable, when the equal to bar was included, we shaded in the endpoint. We made it a solid endpoint. Here we have to make it a solid boundary line instead. So when will we dash it, or the same as leaving the endpoint open, when would we dash it? Less than, is less than, or is greater than. In other words, the equal to part of the inequality is not included. So that's, once we get it ready to graph, and we get those 3 or more points made, once we are ready to draw that boundary line, we have to make that decision. Should I make it solid or should I make it dashed? Are all the points on that line included in the solution, or are they not? If they're not, we leave it dashed. Okay? And then we shade above or below the line. After we have our boundary line made, then we decide where should I shade. Should I shade above or should I shade below? What helps us decide when we should shade above? Is greater than? What's the other possibility? Is greater than or equal to. So either of those. Remember, the equal to part told us to do the solid line. The not having the equal to part said make it dashed. The is greater than part of those two makes it shading above. So then, of course, we would shade below when it is less than, or equal to. So that's another decision we have to make. And then last but not least, we test a point not on the boundary line. We're not testing the boundary line. What we want to test is, did we shade the correct half plane? So did we shade the correct side of the boundary line? So we're going to test a point not on the boundary line. That's huge. Do not pick a point from on the boundary line. I'm not going to make you test the boundary line. Maybe I should, but I'm not going to make you test the boundary line. I want you to make sure you're shading the correct side. So if the point that you're testing comes from the shaded half plane, it should make the inequality true or false. This is like what you did in 2 through 4, 12 through 14 in the homework. You tested to see if a point made the inequality true or false. So if we pick a point from the region that we shaded, should that make the inequality true or should it make it false? In other words, is it a solution if it's in the shaded region? That's what shading will show is, yes, those are all the points. Yes, we didn't do our reading. Those are all the points that are included in the solution region are all the ones in the shaded region and on a solid boundary line. We're checking to make sure we shaded correctly. So if the point we picked to test with comes from the shaded half plane, it darn well better make that inequality statement true. It better be called a solution line. If you have it in the shaded region, that's showing your solution region, it better make that inequality true. But if you decide to pick a point from the unshaded side, you can pick them from wherever you want. Where's the only place I don't want you to pick them from? The boundary line. So you can pick from the shaded region or the unshaded. Well, if you pick one from the unshaded region, you have now just said, I'm testing this one to see if it's truly not a solution. If it's not a solution, it should make the inequality. If it's not a solution, it should make the inequality false. Maybe I should have to keep your assignments for a bit here. So in other words, when you were testing those ones in those first 6 problems of your homework to see if they were solutions or not, if it tested false, you said, no, it's not a solution. On the graph, that means it better be in the unshaded region then. Okay, so let's go to work practicing actually, because solving these is graphing. So we're supposed to solve negative 2x plus 3y is less than negative 15. Well, we solve it by graphing a boundary line, deciding where we should shade, shading it, and then testing a point not on the boundary line. So the first thing we need is we need that to be put in slope-intercept form. So what would be our first move here? You know, you guys did so well on that quiz that I'm like quite surprised that you had nothing to offer when I asked you questions in class. Kate. Add 2x. We need the y eventually to be alone, so we got the 2x to get out of there. So now we're going to have 3y is less than negative 15 plus 2x. What would our next move be, Chase? Divide every piece by 3. So 3y gets divided by 3, negative 15 gets divided by 3, 2x gets divided by 3. As soon as you say the word divided by or multiplied by, let's go back and remember when you're solving inequalities, if you multiply or divide by a negative number, what do you have to do? Reverse the symbol. Did we divide by a negative? No, we divided by a positive 3. So we are not going to reverse the symbol. We're going to leave it is less than negative 5 plus, well, 3 doesn't go into 2 nicely, we'll leave 2/3 x. We are now ready to graph our boundary line. We are going to come over here and we're going to say that m equals and b equals. What's our slope of this boundary line? 2/3. And its y-intercept is negative 5. Okay, so go put some points on your graph. Remember, what's the minimum? 3. And then the next decision you've got to make is, should it be a solid line or a dashed line? Dashed. Okay, why should it be dashed? What's missing in the inequality symbol? The equal to bar. If the equal to bar is not in the inequality symbol, we do not include any points on the boundary line. So that means we are going to make this a dashed line. All it is the boundary. None of the points on it are included. So with your ruler, make a dashed line going through those points. All the way through your graph, don't be skimpy. All the way through your graph, make a dashed line, and make sure that you and I both can tell that it is clearly a dashed line. Some people call it a dotted line. Okay, so next decision we have to make is, where should we shade this one? We have to decide, should we shade above? By the way, where would the above be on this? Left or right of that line? Above would be to the left, and below would be to the right. Okay, do we shade above or below? Below. Why below? Because it is less than. Is less than means below it. So we're now going to, with your pencil, you're going to lightly shade, or shade enough so that you can tell. But we're eventually going to be graphing more than one of these on a graph at a time. So I don't want you to learn to get too dark right away, but be neat at least, okay? I don't have the side of a pencil to be as neat as you can be. This is your opportunity to color. Okay, the next thing we have to do is test a point to see if we have a good shaded region. So we're going to pick a point. We're going to test. And we're going to test a point. Let's test one from the shaded region. Pick an ordered pair that's in that shaded region, not on the boundary line. Somebody name one out. Benton.
0,
0,
0.
0. Okay, it's not in the shaded region. So you want to test that one?
No.
Okay. Austin?
4, -5.
negative 5?
Natasha Howard to the junior high office, please. Thank you.
So right here? Pardon? Did you change your mind?
I said
1
1 negative 5.
negative 5, and I heard it as 4. I'm sorry. Can we do 4 negative 5 since I've already, thanks. Oh, you're so generous. Okay, 1, 2, 3, 4, 5, yeah. We could do 1 negative 5, but it's kind of close to the boundary line, so sometimes you might want to get a little further away just in case it's, you know. So we're going to go with what I misheard. We're going to go with 4 negative 5. Now, when you test it, hear me on this, you cannot test it in your renamed inequality, the one we used for graphing. You need to go back and test it in the original name, just like we do check problems in the original name. So we're going to go and we're going to see it was negative 2x to start with, plus 3y is less than negative 15. That was its original state. We will sub in our 4 for x, our negative 5 for y, and we will simplify down without our calculators. Negative 2 times 4. Negative 8. 3 times negative 5. Negative 15. Bring down our is less than, bring down our negative 15. Okay. What's negative 8 plus negative 15?
Negative 7.
I'll go with a negative 23, I heard. Negative 23. If you borrowed $8 from somebody and then you borrowed another 15, guess what? You wouldn't only owe them $7. It's going to work that way. Okay. So, is this a true statement or not? Now we decide true or false. Is negative 23 less than negative 15?
True.
True. That is true. So it checks out that we say, you know what? We believe we have a good shaded region. Questions? We're looking at the clock. You only have 4 problems to do today, so you can hang in there with me. Because we're going to have Benton's going to get his way in the next problem. Okay. So let's go to the one on the back. Good. Okay. Get that one ready to graph. Go. Get it ready to graph. And then when you're done, tell me if you agree with me or not.
I agree.
Please feel free to disagree. You don't agree. Here. Who's talking loud with a friend? Did something wrong. What's the problem? Divided by a negative, which means I have to flip it. Yes, absolutely. And I did that. You're not going to believe me, but I did do it purposefully so I could see if you would catch it. Sometimes I make mistakes legitimately. This was not actually one of those times. Okay, so be really careful. Make sure. And here's what, well, this is why we don't check in this one. Because if you checked your test point in this one, it will, of course, you know, when I had it wrong, of course it will test correctly. And then when you get to seeing the answer key and you say, well, wait, why is the other side shaded? It's because you forgot to flip the inequality symbol. So by not checking it in the original, you're not going to catch that. Okay? So what's our slope? 1. What's our y-intercept? 2. Okay. So we are going to get our points put on there and then make our first decision, which is, what's our first decision?
Solid.
What? What? I didn't hear what you said. Solid line. You had to decide if it should be solid or it should be dashed, right? I thought you might have said solvent or something like that. Okay. So it should be a solid? Is that what you're telling me? Okay, it should be a solid line because it's why? Why is it solid? Because of the equal to bar, okay? All the way through the graph. Do not be skippy, because I know you have 3 points like I do, very close to each other. Okay, now the next decision is, and we look here, this is where we look, right here, in our renamed one, should we shade above or below? We should shade above, okay? So go ahead and shade above. After you have shaded above, the next decision you make is what should I use as a test point? Now, I said Benjamin was going to get his way. And here's the reason why Benjamin's going to get his way. Because we don't always have to test a point from the shaded region. And 0, 0 is a very nice point to test with. Because what happens when you multiply by zeros?
Zero.
And it makes it so much easier, doesn't it? You don't have to worry about whether it's a positive or a negative 0. So if we test, I want us to put that we're going to test 0, 0. So that right now is not on our boundary line. That's, first of all, we can't test 0, 0 if it's on the boundary line. You cannot test 0, 0 if it's on the boundary line. And sometimes it will be. But if it's not, it's a really friendly point to test with. Should this test true or false? False, because it's in the unshaded region. So we're going to test to see if, okay, we're going to go back to the original inequality, which was
See if it's
15x. 15x minus 15y, and I got to go back again because I didn't think of all of it, is less than or equal to negative 30. Okay, we're going to put 0 in for both of them. 0, 0, 0. On mindless checking. Then we ask ourselves, is this a true statement or a false statement? Is 0 less than or equal to negative 30? No, it's greater than, isn't it? So, do we want it to be in the shaded region then if it tests false? No. Is it in our shaded region? No. If this would have tested true, should you have gone back and done something to figure out where your mistake is?
Yep.
This is why you only have 4 problems for homework. Hear me on this. Hear me on this. You need to be learning how to do this when you get to do one linear inequality on a graph. Because the next lesson we're going to move into systems of linear inequalities. We will be graphing more than one of these on a coordinate plane and having to determine where the solution region is. So you need to make sure you get this down to be successful in the next lesson. So if it does not test, don't be happy to move on. If it does not give you the results you're supposed to get, go back and figure out where you went wrong. Okay? That's why you only have 4 problems. So get out a sheet of loose leaf paper to do all the extra work on. And the graphing. Oh, actually, you know what? There's room right on the graph's hand. How about we just do right on that?
You know.